Hi everyone, welcome to questions on periodic table and ionization energies. First question we have here is asking us which element contains atoms with the largest radius. Now I'd refer to my periodic table, so I'd look and I'd see I've got potassium and sodium in group 1 and I've got magnesium and calcium in group 2. Now I know that as I go down the group, the radius increases because I'm adding a shell or energy level each time I go down the group. So therefore that means that potassium is larger than sodium and calcium is larger than magnesium. So I can cancel out A and C. Now that leaves me potassium and calcium. Which one's larger? Well, the answer is B, potassium. Now that's because calcium has an extra proton, therefore has a greater nuclear charge and greater attraction between the outer electrons, so therefore has a greater pull, so it brings it in a little bit more. So potassium just edges out there on calcium. Question 2, which trend is correct? So again, if you know straight away, then great. If not, go through them. Process of elimination, cancel them out one by one. So if I start with melting point decreases from lithium to carbon, that's not correct, it should be increase. Boiling point decreases from fluorine to iodine, well again that should be increases because fluorine starts as a gas, iodine is a solid. First ionization energy decreases from lithium to cesium. Well, that is correct, so we'd go with C being correct. So hopefully, again, go through bit by bit, make sure you're happy with it, take your time with it, even though it is worth 1 mark, so you're roughly looking at a minute per mark. If you need to then spend more time, maybe come back to it later on. Okay, so we need to write an equation for the first ionization energy of chlorine, include your state symbols. So these need to be in the gaseous state, so if you remember the definition, first ionization energy, you need to make sure that it's in the gaseous state and forms 1 plus, again in the gaseous state as well. So we need chlorine in the gaseous state, chlorine plus the gaseous state, plus that electron that's there. Okay, and here we have the final question. We're given some successive ionization energy values. We're asked to say what group it's in and then give a justification. Now, when you're looking at these values, you're looking at the differences, looking for any big jumps, because that signifies a new energy level or shell. So if I look at the 3rd to the 4th and 4th to the 5th and so on, I can see that roughly the increase is about 2,000, maybe a bit less, maybe a bit more in places. If I look at my 1st to my 2nd, I see an increase, I'm expecting an increase. But then from my 2nd to my 3rd, it's nearly 5,000. Which is the biggest increase between any of the ionization energy values. So that tells me that I remove the first electron, remove the second electron relatively easily, compared to the 3rd one was a really big jump. So that tells me those 2 electrons, those first 2, were in their own shell. Once I remove those, I move to another shell closer to the nucleus, greater attraction to the electrons, therefore harder to remove. So therefore that tells me those 2 electrons in their own shell, in that outer shell, must be group 2. And then my reasoning is that large increase from the 2nd and the 3rd energy level ionization energy values. Okay, so that will do us for today on periodic table and ionization energies. See you next time.